introduce our speaker. Nicole Masters is an independent agroecologist, systems thinker, author, and educator. She is recognized as a knowledgeable and dynamic speaker on the topic of soil health. Her team of soil coaches at Integrity Soils work alongside producers in the US, Canada, and across Australia, supporting producers who work with over 1.2 million acres to take their operations to the next level in nutrient density, profitability, and environmental outcomes. She is one of a growing number of people who are facilitating a rapidly expanding world of quality food production and biological economies. Her book titled For the Love of Soil showcases examples of the tools and principles producers are using to regenerate their soils, describing a step-by-step triage of actions so that you can too regenerate your land. So we are pleased to have Nicole Masters with us. And just a few housekeeping before I turn it over to Nicole. You do have two buttons. You have a chat and you have a Q&A. So the chat we're going to go ahead and use right now. So go ahead and put where you're from or where you're watching from. That'll get you a little bit used to using the chat feature. Now the Q&A, if you have any specific questions regarding the webinar, please use the Q&A tab and we'll go ahead and get those answered at the end. All right, Nicole, I'm going to turn it over to you.
Brilliant. Thanks, Alex. Thanks for having me and the whole ward team for initiating this webinar. I can see some pretty awesome names on this list of people that are actually on the call. So thank you for making the time. Please ask questions as we go. I was saying to Alexis, this is one of the most challenging presentations I've ever had to put together because, you know, I'm sort of aiming for maybe 50 minutes where I'm just going to share some things and I invite you to ask questions as we go along. But I've been given such a broad topic, I had to kind of choose a narrower aspect so that we could really dig into something. So I've chosen just to focus on the bigger three, I guess, the NPK, and how that relates to what we're doing with regeneration. So there's people from Miles City, there's people from Iowa, Colorado. Nice to have you on. So thanks. Please ask questions as we go. And actually, Alexis, if you see a question that relates to what we're talking about, then yeah, shoot away. I'm just going to share my screen. So some of you are on the phone, so we won't be able to see the screen, but we are recording this, aren't we, Alexis?
Yes, we are.
Yeah, so we will be able to see. So bringing tests to life. This is one aspect of when we're thinking about regeneration, is really looking at how do we actually measure and really show what we're doing in terms of regeneration. Okay. So just some of my thinking around regenerative farming, it is a very complex learning system and it's a whole system. So if we're talking about nitrogen or phosphorus, we're not talking about them in isolation. And it very much is what works well in your local context. How is the environment affecting mineral and microbial balances? How is your stock class or crop type, yeah, affecting all of these different outcomes. And really, when you look at a definition of regenerative agriculture or agroecology, they talk about producers as being the experts. So I really, you know, in doing these presentations, so much of this has come from what people are experiencing in the field and what people have been willing to share with me. So I really think of this as being a pyramid in terms of learning. And so the base of this pyramid is your education and observations. So doing webinars and podcasts, and in the old days, once upon a time, we used to do these things called workshops and conferences, which we will tell our grandchildren about one day, I'm sure. And how that education just really feeds into our observations and being able to inform management. And what I call the limiting factors or enabling factors. So what are these? What's putting a drag on your system? Looking at increasing biodiversity, stimulating and feeding microbiology, then looking into what some of these like broad spectrum fertilizers, carbon-based nutrients, your trace elements and refinements. But the foundation of that really is your education and observations. And what underpins all of this is your mindset. So a mindset, for me, the definition of regenerative agriculture is your mindset. Do you see the world as opportunities, as indicators, or do you see it as being outside of your responsibility? Like, you know, the weather's to blame, the government's to blame, my neighbor, my wife, whoever it is, instead of actually where am I personally responsible and where can I take new actions. And for me, that's all that regenerative agriculture is that mindset. So something's been coming up a lot for me in the last year is really looking at if we're regenerating, we're not just talking about soil, we're not just talking about the environment and water, but we're also talking about what's happening with animal welfare, the quality of what we're producing, the profitability and success of your business, your connection to land and the family, self-care, all of that stuff. And what I see is where are we willing to kind of compromise? Like, where are we like, yeah, I'm 5, I'm off the scale, I'm really achieving all of my goals, to actually self-care has fallen away. Or I see people like really building soil. Man, can you build soil really fast if you're willing to compromise, say, on animal welfare or profitability. But where is it that we can actually have a system that fulfills as much as possible on all these different elements? Or maybe do we need to bring someone else in to help us understand or interpret or manage or whatever it is so that we can fulfill on all of this, so we're not dropping the ball in certain parts. And I certainly see producers like to drop the ball on self-care. So I'm just drawing attention to this to really think about, are we regenerating every single aspect of our operation and ourselves? So I'd like you to consider for a minute, what is it that's putting a drag on your ranching or farming system currently? You know, is it you? And maybe it is. Is it not having access to finances, maybe, or having a crew that can really help, or whatever it looks like? So for me, when I'm thinking about soil health, I talk about it in terms of the 5 M's. So what's happening in terms of minerals, microbiology, organic matter, it's cheating a little bit, your management and your mindset. So those are the 5 M's. And so we use this as a diagnostic tool to figure out, why is it that we're not achieving all of those goals? Why are we not necessarily as profitable as we want to be? Why are we not really looking after ourselves? Why are we just running to stand still? But all of these feed down into soil health. So when I'm looking at how I identify those 5 M's, I am going to do some mineral or microbial testing and leaf tissue testing. Field observations are absolutely essential. Are you digging holes? Are you taking records? And are you taking records over time so that you can trend changes? And then are you taking that time to self-reflect and look at, you know, that big picture, working on the business, not in the business, and really taking that time to assess, where is it that my system's not working as well as it could? And am I just running around in circles? So you do hear different people talking about there is no need to do mineral and there's no need to do any testing whatsoever. And I just call BS on that. And I also call it that if you are talking about regenerating, if you are saying that in your language, like I'm a regenerative farmer, if you are selling your meat or your grain or your milk and saying, you know, we're doing this regeneratively, you need to have these numbers behind you to say, really am improving the quality of my land and the outcomes of what I'm doing on this land. I'm improving water quality, I'm improving nutrient density of meat or milk or whatever it is that you're growing. But what I notice is the people that say you don't need to test have a lot of testing behind them. Have a look, you'll see they've probably got like 10 or 20 years of historic testing, so they can really demonstrate, I have been doing this on my own piece of land. If you're not, it just amazes me how many times people run into walls or they hit a platform where they really don't improve. They kind of reach this level and they just sort of stay there. And it's because they're not doing that testing to identify what is it that's putting a drag on my system. So I really encourage you, if you haven't been doing testing, to start doing some testing. I don't know who said this quote, actually, I can't remember, but yeah, without measurement, there is no management. So you need to be able to assess, which way is my program going? Is it going forwards or backwards? And the number of properties that have gone into and we've dug holes and people have been absolutely shocked by the degradation of their soil, by hard pans, by total compaction. And it's really only by having a control, having an area underneath the fence, that you can really see, oh, actually, I might be part of this problem. And so our testing just falls into a part of this. So why is it that we want to monitor at all? in part so we can get immediate feedback. Like I want something that's actually going to inform my management this year. You know, and I've been to places that have like 10 to 30 years of transect data and they've never used it. They've never really looked at, well, what does this say about my management? You know, is there things that I need to change in here? And it's almost like it's just data for data's sake that sits on a corner, on a shelf, so we look at again. This monitoring for me needs to have a point. There needs to be something that I'm investigating or I'm looking at, or I really want to, to benchmark. So we might be looking at with the tissue tests for crops that respond really quickly. I see there's quite a few cropping guys on this call. That monitoring is going to enable us to assess if there's something I need to do in terms of refinement, so small amounts of, say, a trace element or some kind of biostimulant in the season that's going to give me a response by the end of the year. We need to be able to identify excesses or deficiencies in the soil or plant. Does that mean that I'm going to try and make my numbers perfect and like make my soil just like incredibly perfectly balanced? For me, no. Like I just I don't believe in it, because what we've seen is biology can do some crazy things. And once you start to get that system rolling, it starts to take care of itself, and you just need to get out of the way. We could be monitoring because we need to look at optimizing water to gain information on our management and to inform future management. The one thing I like about monitoring is what I call the smug test. So where I'm testing across the fence with a neighbor that's willing to be tested against, and just like, you know, I feel quite smug. I'm doing quite well compared to what the neighbor's achieving. Not to put the neighbor down, but you know, there's that smugness. So if we're going to test, I want to be able to compare the same site over time. And it amazes me how often people just go and randomly sample in different places all the time. And it doesn't give you enough information. It might give you information if you're a fertilizer salesman. You know, they come in and they do these W shapes and they'll sample all across the field. They will never repeat that test. They will never be able to come back. And there can be as much variation in a field as there is between fields. So I generally set up like a 200-foot or 60-meter long transect, and I'm going to sample along that line. I'm going to sample soils, mineral, microbial, and a leaf tissue test. And I'm going to take it at the same time of the year and hopefully with the same kind of moisture. I'm going to make sites easy to get to, so it's easy for me to replicate. There's no point if I've got 50,000 acres putting it right up the back of the ranch that I'm never going to go up to again. It's really good to compare site-to-site comparisons where maybe you've got different management, or you're doing different types of treatments, or maybe you've got an area that's causing trouble. Like maybe you've got an alkali area, maybe you've got just some kind of heavy metals or some kind of issue going on, or it's been historically abused, like it's been old farm ground. To be able to monitor that and then compare that to areas that are under different management, so you can really see, you know, am I significantly lifting that, or is that variation just because it was a good season, right? So we need those controls. So what I want to talk about is the big three. So nitrogen, phosphorus, and potassium management. So, you know, these are the big fertilizers that have really driven the green revolution. But I want to talk about them from a biological context. So I know this graph is really overwhelming, and you know, you get shown these when you're at university and you're like, well, never going to remember all of that. But what I want to draw your attention to is how much of this nitrogen cycle is biological, right? But what's really interesting about it is the bit in the middle. So you look at where the decomposers are and where the protozoa are grazing. This is actually the biggest drive of nitrogen up to the plant. So that cycle that goes from nitrogen in the atmosphere to ammonia to ammonium to nitrates, that is all about bacteria. And I think of them as like bags of fertilizer in the shed. They're zipped up and they're not open. And that nitrogen cycle is basically bound in the bodies of your different types of bacteria. And it's actually the protozoa and your different types of your nematodes that are there to actually release that back to the plant. So the membranes of biology are full of amino sugars, basically. So the protozoa can come along, or a nematode comes along and grazes and eats that bacteria, and then basically, like in a nematode's case, it actually vomits it to the root zone, and there goes our nitrogen cycle. And another big part of this is your mycorrhizal fungi. So glomalin is actually a type of protein, so it's a nitrogen again. So your biggest source of nitrogen is actually from these higher organisms and from having that whole microbial spectrum working and functional, not from fertilizer, right? It's how do we stimulate that biological part? And what's really interesting is if you see what people are still being taught at university, they're not being taught about protozoa and nematodes, even though that's the biggest release form, right? So you need to be looking microbially, do I have those organisms in the soil and are they functioning really, really well? So these are your nodules on your legumes. Start pinching them and having a look. Are they blood red? It's called leg hemoglobin. And what you find is on most operations is they'll barely have any nodules whatsoever. And if they do, they're probably white or they might be green. So green means they were fixing nitrogen and they've stopped. You need to get curious. Why did it stop? Maybe you applied nitrogen fertilizer. That'll do it. Maybe you put manure out. Maybe it just got really, really cold. If they're white, they've never been fixing nitrogen, even though they've formed that nodule around the rhizobia or different types of bacteria, they're not fixing nitrogen. And potentially there's two trace elements involved in that. One is cobalt, one is molybdenum. Are they lacking in the soil? Is it because you're low in organic matter, you're low in biological activity? Are they putting a drag on those trace elements, which is then affecting your whole nitrogen cycle? So your free-living nitrogen cyclers are the ones that are also affected by cobalt and molybdenum. And so if your nodules are not working, then the ones in the soil potentially aren't working either. So get really curious about this, because it amazes me how we just assume our nitrogen cycle is working because we have legumes out there and they may not be fixed. The nitrogen's interesting in terms of it's all about aggregate structure having crumbs. And so the more compacted you are, then down goes production. So compacted soils need more nitrogen and lose more nitrogen. So have you ever noticed how if you drive through a field in the same place, how the growth is lower there? So why it's lower is that's the effect of compaction. It's a yield drag, right? So that you've actually potentially got that effect across your whole property, and yet it's unseen because you're not really thinking, oh yeah, my whole place is compacted. All right, so it's a vicious cycle in terms of as those soils get tighter, you lose gas diffusion, we lose those crumbs. And I want you to think of those crumbs are a little bit like nodules on a legume. All right, so inside those crumbs are like little nodules. They're anaerobic right inside, and that's what that nitrogen fixing organism needs, right, to create the enzyme to fix nitrogen, right? So we want crumb structure, not wells. And lose up to 10 times more nitrogen from the compacted soil. So then you need more inputs. On some properties in New Zealand, I've met farmers that are putting on 680 pounds an acre of urea, let's say. Yeah, urea. To try and grow the same crop that, 20 years ago, they're probably doing on 100 pounds, right? We're needing more and more and more. So there's different factors affecting the nitrogen cycle. So there's a long list there, but what I want you to look at is nearly all of it is about structure. Nearly all of it is about what's happening in the soil in terms of soil health. Have you got adequate moisture, temperature, but compaction, aeration, texture, soil organic matter, having plant root system deep and functional, and having all your crop residues, right? So in New Zealand, 78% of New Zealand dairy farms are considered significantly compacted. So here we are, we're compacted, now we're going to need more nitrogen, and then you put more nitrogen on, and in that process, the bacteria actually, they need to draw carbon out of the system to balance their carbon to nitrogen ratio, and your soils get tighter and tighter. Have you ever seen that in alfalfa fields where you can barely get shovel in? Because what's been happening is if you've been maintaining, a high alfalfa stand, they're pumping carbon into that soil, pumping nitrogen into the soil, and the biology of pulling carbon out to balance it, and it makes that soil tighter and tighter and tighter, right? So we can reduce nitrogen with no yield loss. One way to do that is to manage your residue. So we're recycling your nutrients. We want to stimulate your microbiology. Get diversity in there. If that's cover crops or multi-species forage crops, if you are applying nitrogen, you put it on when your crop needs it rather than putting it on the fall before or autumn before. test before you even put nitrogen on. Often people are diagnosing a nitrogen deficiency and it's just not. I would say on nearly all the cases, on all the properties we go to, it's not nitrogen that's your problem. All right, so test it, do it a leaf tissue test and a soil test to have a look. If you are using nitrogen, put it has carbon. Carbon and nitrogen exist in all living bodies together, right? You have a carbon to nitrogen ratio like 30 to 1. Bacteria have a carbon to nitrogen around 6 to 1, but they draw more carbon and nitrogen out of the soil to try and balance their bodies. All right, so make sure you're always putting carbon in. If you need a bit of nitrogen, maybe just a tiny bit of a foliar feed, but often it's your trace elements that's the problem. So particularly manganese. So take a look at manganese, what's happening with manganese in the plant. It's so essential for the whole photosynthetic pathways. I just want to show an example. So this cropping client, they were putting on 90 units of N, 30 of P, and 20 of K when we started working with them. All right. You look at their leaf tissue test, this is what they look like. So highly deficient in nitrogen, phosphorus, and potassium, even though all of them would be deficient in boron. And then when we dig holes, this is what we were seeing. So in their entire cropping history, those roots have potentially never gone deeper than 1 to 2 inches, right? They're not even making the most of what's happening in terms of nutrients in the soil. Their whole biological system is crashed. And now, now you're basically hydroponically grown, right? So those trace elements have a big role in what's happening in terms of, say, boron, so sugar translocation, so sugar actually moving through the plant and then out through the roots to feed microbiology and build carbon. So these guys are basically just sitting in stasis, and they could continue to put NPK fertilizers on and grow high yielding crops, I guess, unless they get a frost or the wind comes or insects come. You know, they become so incredibly vulnerable when you see systems like this. So in 2017, so the very first year working with them, we dropped nitrogen down to 25 units, their phosphorus to 1, their K to none. Potassium they were high potassium soils, it wasn't a problem. This photograph shows what we did. I think that's year 2, but you see all that flocculation. This photo was taken in the same site. You're seeing these soils actually loosening up by the action of biology. They're actually breaking down and decomposing the stubble. And so in the program, we also put trace elements. We put in some humate, gypsum, some mycorrhizae. When I talk about we're doing some trace elements, I'm talking about like 100 grams maybe of a trace element, if that, like tiny, tiny amounts, just to stimulate the microbial system and get it working like that. This is the goal of any of our programs. As we start to open up and get gas diffusion, your nitrogen cycle is now going to start to work. So this is looking in the same field, comparing wheat to wheat. So notice the nitrogen. So even though we've gone from 90 units to 25 units, the nitrogen actually went up and it's actually still in excess in this field. Sulfur's come down, potassium's come up, and a big part of that is potassium is bound in the plates of that soil. As we start to flocculate, you'll see a lot of potassium being released. How you would see that if you're a grazier, what you're going to notice is the broadleaf weeds. So as your soil flocculates and opens up, out comes potassium, and we see the stimulation signal for broadleaf weeds. Don't panic. It's part of that soil healing itself, telling you that your repair cycle, you're just going to ride it out. I don't know, that's really hard for some people to ride it out, but I talk about it as the ugly hair phase, which you guys don't understand, but girls do, right? So you like year 2 or 3, it's not going to look pretty, and then it starts to grow out, and we start to see diversity coming in. So it's just a natural phenomenon that we start to see. So yeah, notice that the trace elements have all come up, and we're starting to lose all that variation basically, and that's by putting small amounts in. And what I'm interested in is what is the plant experiencing, right? How does that show up? For the producer, how this showed up, it was in a reduction in the passes required, so the amount of fuel. Their pesticide use was dropped by 95%, herbicides by 40%, fuel by 20%, and their cost for fertilizer inputs dropped about $100 an acre. That's all profitability while we're opening the soil up and really taking care of stewardship. I'm often loath now to sort of show examples from individual farmers because you're only seeing it like a small snapshot, and it makes everything seem like, oh, it's all glossy nirvana. There were like lights coming down from the sky and it was also perfect. I've never met a perfect producer, right? Everybody's working on something, everybody's different goals that, you know, some things are working really well and some things are not working really well. So I think you've always got to take everything that you hear about everybody's stories with a grain of salt. But certainly for this operation, profitability was a big outcome for them, and a surprising outcome because it's actually not why they wanted to start on a biological program. Phosphorus is the other of the N. So phosphorus is essential, obviously, in determining healthy soil. It's the primary catalyst in adenotriphosphate, so your ATP cycle. We need it for growth. We need it for animal health, we need it for bones, flower, seed production, quality, seeing plants grow better in cold temperatures. You know, for those of you in the north, you know, are we getting good phosphorus mobility? It helps with your water use efficiency and early maturation, all right? So people that are just putting phosphorus down and high soluble P with the seed, you're gonna find that engine room's gonna run out really fast. And what it does is when you put that soluble P down, it sheds relationship with mycorrhizae, which are the main way that phosphorus comes into the plant. I won't show you that. This is just a conventional kind of picture about, you know, you put this much nutrient on and you're going to lose this much from nutrient removal. But what I want you to see in this picture is where is it that 80% of your phosphorus is coming from? And it's this circle in the top and middle, which is your plant and animal residues. 80% of phosphate is coming from plant and animal residues. Your unavailable phosphate reserves can be absolutely massive. And if you farm like the previous guys where you've only got 2 inches of soil, you are never going to access this phosphate. How you access that phosphate is by getting those root systems down, by opening soils up, by stimulating microbiology, in particular mycorrhizal fungi, having animal byproducts and manure and urine to get that whole unavailable pool stimulated. So factors affecting P availability. Same thing as nitrogen, right? You can't buy any of this stuff in a bag. Well, you could run an aerator, I guess. There's some machinery in this. It's not about having phosphate that we're putting into the system. It's about phosphate availability. So think, okay, phosphate is available when soils are very cold. How do soils? You get your bacteria very excited, right? And they will start to metabolize and respire, and they'll actually warm soil up quicker. Get mycorrhizae connected as early as possible. Develop root systems like this. So these are what I call the Rastafarian roots. So see that redlock type structure? That's going to significantly improve your phosphate uptake and your buffer against texture, aluminum, whatever's causing some kind of disruption that you're getting root systems down. We develop those rhizosheets. So that list again is about soil structure. It's about carbon. It's about building organic matter, building loose soils like this that are going to help with your phosphate availability. Anytime you're thinking about anions, so that's nitrogen, phosphorus, and sulfur, those things can move fairly freely in soil. I mean, phosphate, obviously, it's got a triple bond. It's less moved because it's attached to the colloid, or it's attached to, not the colloid, to calcium or calcium or aluminum. All right, so it's bound and then not readily available. But if to work with microbiology, that's who's going to make this stuff available. So the first thing we want to look at is stimulating our bricks. So plant photosynthesis. Is that plant photosynthesizing as high as it can? Are you optimizing what's happening with sunlight capture? Because that's going to drive the whole system, get sugars down there, get those rhizosheets developed, get diverse, deep, multiple different types of breeding systems. You know, he's got like permanent clover crops where he's planting corn into it, having that kind of different types of root architecture. So your different types of cover crops. So buckwheat, oats, and winter rye are all very well known to liberate phosphorus. So buckwheat is non-mycorrhizal. but releases some really powerful acids will help release that bound phosphate. And then stimulating, or I'm not a big fan of inoculating mycorrhizae unless you're at zero. So stimulating mycorrhizae and your phosphate solubilizing bacteria. I had a workshop that got cancelled that was about making these biostimulants yourself, basically. So you don't need to go and spend an absolute fortune. They're all very, very simple to make. And thinking about what's happening with root architecture, are you growing crops that are even fit for purpose? And what we've seen is many of the newer wheat cultivars, you know, big production, they don't have relationships with mycorrhizae. So this picture here is kamut on the left and wheat on the right, just standard wheat cultivar. But just notice the difference in the size of those root systems planted on the same day, side by side, totally different stuff going on in terms of soil and soil management and what's happening with microbiology. So this is something I came across. I used to work in the organic pip fruit industry, so apples and pears, and seeing that these crops were growing for high input systems. They are designed to have all the nitrogen and phosphate fertilizers. They don't have to be resistant to you know, pests and diseases, because you're obviously going to be spending money on fungicides and pesticides. So for kamut, it's never had to be, you know, it hasn't been bred to deal with a whole lot of fungicides and pesticides. So it has to design a system to be disease suppressive in itself, instead of these crops that are like, oh, can you protect me? Can you spend some money? So yeah, is it fit for purpose for what you're trying to produce? You know, and I think more and more grain guys are looking at this, you know, swapping grain. So potassium. So 2 to 3% in our grass leaf sample. Animals actually only need 1% for their own diet. So it's more of what it needs in terms of growth. It's a catalyst, so that means it stimulates other activities in the plant. It's part of what constructs your chlorophyll. And then plants need potassium to make your starch, sugar, proteins, vitamins, and enzymes. I really like, I don't know who came up with this, but it's cool. So calling potassium your poor man's irrigation. So it controls the osmotic pressure in cells. So it's what keeps cell turgor, so how strong a cell is, and basically controls that through the opening and the closing of stomata. So plants that become very wilted and stressed, it's often because they become dehydrated because the stomata did not shut down. So effective in terms of drought resilience, for keeping moisture in the plant. It's essential for growth and size and strength and sweetness, and it moves from the soil solution. So potassium has a relationship with growth and diseases. So we see there's a definite relationship between phosphate availability and fungal diseases or bacterial diseases or viruses. So I've seen quite a lot of alfalfa with virus in it. And you know, we know that, you know, alfalfa or things like corn, they need a lot of potassium, and a big part of that is because of disease and insect resistance, right? And yeah, it has a relationship with nematodes and insects and mites. So when we see it deficient, you'll see those yellow specklings on alfalfa. Necrosis, so that means it's actually dying. You get tip burn, or interveinal chlorosis means it's yellow in the veins, all right? And we'll see more crop diseases, okay? So definite relationship with potassium in that. Poor growth, small fruit, reduced root system, so digging holes again and having a look, you know, is potassium working in the system? And lower nitrogen absorption. One thing when we see these very high potassium soils, and some of you up through Alberta and more towards the west coast will see, you know, really, really high potassium. What that does is it creates very hard, tight soils. So basically it's like a magnet and just brings soils in tight. You've got these plates. So in those plates of your clay plates is potassium is sitting inside those plates. It pulls them nice and tight. And then we have these soils that are just super hard to work with. But they're also an engine room, right? So it's a lot of potassium, you can grow a lot of crops. If it's an excess, so let's say you have a high soil potassium to magnesium ratio, so that means magnesium's lower, potassium's higher. If that's greater than 1.5 to 1, which you'd have to see a soil be really stuffed to do that. I mean, it's not common, but you will see magnesium deficiency. So this is a magnesium deficiency. Excess potassium can also inhibit calcium and boron uptake, and then we'll see calcium-related disorders, so blossom end rot, animal health issues, joint health, bone health, metabolic problems. If it's in excess, your cow urine will burn the grass. And there's a couple of you that probably just gone, you see it a lot. Yeah, especially through, I guess, the Midwest and the Western part of the States, as we see big cow urine patches, all right? They're taking up an excess of potassium. You need to make sure that those animals have constant sodium availability. So you want to be giving them sea salt till the cows come. No, you need to be giving them a lot of salt, free choice. Don't ever let it dry up, because if you have a sodium to potassium pump in every single cell of every single living creature, the body doesn't differentiate between potassium or sodium, and so we can end up with massive sodium deficiencies and high potassium. Worst case scenario, you'll see dead animals. All right, so there is a relationship with nitrate poisoning, milk fever, and bloat, because in part the other cations, so calcium, magnesium, are decreased, sodium's decreased, right? We'll see red clover disappear as well. So it's very sensitive to an excess of potassium. And then what you'll see is dandelions, and I'm sure a few of you've got that, right? So seeing a lot of dandelion, or just broadleaf weeds. Now, the really fascinating thing about potassium is there's heat in the soil, absolutely heat. So maybe, let's say in an average soil, so 150 millimeters, so 6 inches deep, you might have 20,000 kilos of potassium, or about 18,000 pounds an acre of potassium. But plant available potassium is typically only 0.1 to 2% of all the potassium that's in that soil. So you'll see, I mean, it just amazes me. There's been so much work done to show that potassium fertilizers don't really contribute to plant growth. So we go and pour this stuff on. It's more around availability. All right. So what is happening in terms of how do we get that functional? So one of the elements involved in that is manganese. So small amounts of manganese can lift potassium mobility into the plant. And what's interesting is, and many of you know this, is that glyphosate binds manganese, which may contribute to poor potassium uptake and reduce your yields, as well as increasing plant diseases. Right? So they've got this thing in viticulture, if you're in any of those grape growing areas, that they call manganese disease. All it is it's glyphosate. So excess of glyphosate binding up the manganese. So the best source of potassium, so I could have given you this whole list of fertilizer potassium, but the best source of it actually is organic matter. So trampling, manure, urine, stubble digestion, what it does is it produces your uric and carbonic acids, but it also produces potassium carbonate. So it takes that potassium in, which is, you know, the highest element in terms of your nutrients in a leaf, and turns it into a carbonate form, which then becomes very bioavailable. Now you want to be trampling that down and having it digesting and then being released as a potassium carbonate. Now, that picture at the top probably has a little bit too much litter for me. Now, you don't want to compost your whole or mulch your whole ranch or farm. That's actually not conducive, because you're going to slow yield down. You know, when you mulch your garden to keep your weeds down, you don't want to do that by having too much litter, but you still want to make sure that you've got plant contact and that we're getting that breakdown, because that's what's going to help make your potassium highly available. And what we see then becomes some significant chemical and biological changes. So as biology kick in, that leaf litter breaks down, those carbonic acids release bound nutrients like phosphorus, potassium, calcium. And what they also do is they drop your Al and your sodium, right? So if we're testing for this, now it's really difficult to predict it. All right, it becomes very, very difficult to predict, because you're like, all right, I've just changed some of this management, and then suddenly that phosphorus or calcium mobility comes right up. So grazing management is an essential part of this. So if you have got livestock, to increasing potassium, So we want to make sure that it's all the same rules, right? So adequate recovery, having high stock densities, and having a different diversity of animal species in there. So we are contributing to the different biological pools, and we're putting that litter down on the ground. So addressing compaction and waterlogging and creating those aggregated soils is key to potassium, phosphorus, and nitrogen availability. It's all about aggregation and gas diffusion, all right? That's what's driving it, is your microbial partners, right? So your mycorrhizae are your mining crew. So that's mycorrhizae actually getting into like rocks, okay? So they can get in there and have very powerful acids and extract rock off. You are never going to run out of soil, like the building blocks, the minerals, that sand, silt, and clay, right? You're sitting on it, that's just not in that unavailable form, right? And I see Ward have a number of different types of tests, so we can look to, is that what's sitting in my soil? And then do something like your Haney test or your Malik 3 test and look at, is that plant functional? Is that actually a functional element? One way I think about it is in terms of, you can test like total nutrients, and that tells you what's in your bank account, but those Malik tests and your modified Morgans, those tests tell you what is your daily bank card limit. How much nutrient can you actually get out of the system? So this is one of the things that we see increase with time, is your bank limit increases. So if you have $1 million in the bank account, but you have a daily limit of $1, you're starving, right? Your crops are not going to grow, things aren't going to go well. As we start to increase our daily limit, which is all about microbiology, then we start to see quality and yield coming up in response. So I want to show an example of this in action. So Injulin Ranch, they're in Big Timber, and actually it's where I am right this minute. You see the crazies out the window. So we did 2 alfalfa treatments. So the biological received 2 gallons of fish, 10 pounds of trace element, which was based off the soil and plant tissue tests, 8 ounces of a humic acid. It cost about $20 an acre for this. Also put in Bovaria bassiana. If you can see that picture, you see there's a lot of alfalfa flea. So Bovaria bassiana is a biocontrol. It's what we call an entomopathogenic fungi. So it's a fungi that eats insects specifically. So that was also applied because it's very difficult sometimes to get a step ahead with the amount of grasshopper damage or root weevils that are going on in the system if they're constantly chewing away at your roots and at your leaves. So for a transition tool, I think they're quite valuable. So yeah, we compared that to conventional NPK fertilizer, and that was applied using this slurry sprayer. So the reason I like these slurry sprayers is that we can put up to like 40% solid, like we can put in fine calcium, we could put in seeds. So this actually spray seeds. So it's highly aerated, like this thing's just fully agitating, and then it has a trash open diaphragm pump, right? So we're applying different things that would, this blend would be fine to go through a normal sprayer, as long as you have soluble trace elements. But yeah, when we start getting out in terms of wanting to be able to put seed and stuff, having a equipment like that gives us a lot of flexibility. So what we did is we did some forage testing, and we looked at what was happening in terms of quality. So the first green graph bit is what would be termed supreme alfalfa or lucerne, right? So what does it need to be over in terms of crude protein? So the control NPK was just under what you want for supreme, whereas the alfalfa here was at 30%. Now this is not just a pure alfalfa stand, it's also got grass in it, because 30% protein that's a big power pack, right? And so if you just fed alfalfa just like that, it's probably going to go straight through an animal. Your neutral detergent fiber, so you want this to be lower than 34, and it's 28 in the bio block and 37. So neutral detergent fiber, so the fiber that the animal needs in its rumen, but if you have too much, obviously that's going to slow down meat and milk production, right? Too much fiber. digestible nutrients, you want that above 62, and the BioBlock's at 70, right? So the relative feed value, this is the really cool thing, the relative feed quality rather. You want it over 180. So it had gone from 155 in its normal program and in the control to 222. What does that look like? What that looks like is you can, animals will spend more time down, they'll spend more time chewing their cud. You will have more effective land, basically, or you could run 25% more head of cattle, which is what this operation chose to do, right? So you can increase your stocking numbers. If you put that into your, if you put this into, say, a feedlot, it's going to mess with your rations, right? Because they'll leave a lot of forage behind. Right, so it's all about quality. And so we achieved that quality on $20 an acre. Now, this is the bit that I found really fascinating. I showed this to the local vet, is we tested hairy vetch. So this was out in the distance of this photograph on some farm ground, old farm ground, looking at the treated to untreated. So I took out things that weren't really significantly different. So slight increase in nitrogen, phosphorus, calcium, a doubling in magnesium, an increase in zinc, manganese, and boron, which is all fabulous. But what's super interesting is a lot of ranchers have problems with an excess of molybdenum. Why that's a problem is out here, it locks up with copper and you can end up with some real animal health issues, animal performance, weight gains. They can't actually uptake copper very well at all. So, you know, some people are having to inject different types of multimin to be able to get it in. So just, yeah, so this was $20 an acre of a bio mix. So it had the fish in it. Is that the molybdenum dropped from 8.3 to 1.4. So that's actually a game changer. Up here, it's not unusual to see molybdenum over 20, 20 to 60. And we've seen it again and again. As we start to stimulate microbiology, that molybdenum comes down, even though it's excess in the soil. And that's part of building that rhizosheath, right? Is that if you don't have a rhizosheath and you've got little naked roots down there, they have to take up what's just there in the soil solution. Like there's no buffer for biology to choose what is it that you're able to uptake. So by building a microbial population and the rhizosheath, you now have a buffer and the plant can say, hey, I just need it in excess, right? And then that's going to have a flow-on effect in terms of animal health and performance. So as a result of the program, their bricks doubled to 20. What does that mean? You've got real, that's in part of what's relating to that relative feed quality. Animals are going to do well. Reduction in pests and diseases. So yeah, yeah, we did put the Bovaria in there, but I wonder, even without the Bovaria, so the biocontrol, if you get your bricks up over 20, then we don't see insect attack to this, right? Definite faster recovery after grazing or haying. This was the last cutting for, so this is 2016, really cutting for hay, and they cut an additional 1 ton per acre of hay crop. Well, that extra additional $100 an acre of income then pays for their treatments out in the farm ground, right? So I kind of believe in paying it forward. Like you're not going to go and spend a fortune and put some trace elements out onto rangeland, for instance, but if you can generate more income on your higher productive areas and then pay it forward, it makes a lot of sense to me. Okay, so I'm not seeing any questions on the chat. Should I wonder if I keep going?
There's a couple on the Q&A that I can see.
Oh, there is?
Yes.
Okay. Oh, it's not showing up on mine. Oh, it says my Q&A session is inactive. Do you want to read them to me?
Yes, of course. So I've got a couple in our Q&A, and then we have a couple that were actually emailed to us. So I'll go ahead and just start knocking them out. So the first question is, every farmer does not want to be a complete regenerative farmer and wants to understand how and what he can manage to obtain some of the free nature provided resources. The complete regenerative farmer would, in my view, require a different set of tests from such a farmer, and the context becomes important. Do you agree?
Yeah, I totally agree. I think everybody has different goals and different outcomes that they're wanting to achieve. But, you know, out of all of this, who doesn't want to see resilience and profitability and more freedom to free you up from other things? So what I find is people might start and they're like, okay, all I want to do is save some costs on inputs. And that's a good place to start. And then it starts to open up doors like, oh wow, well, I'm seeing better water holding capacity, and I'm seeing a reduction in the need for pesticides. And I just, you know, so I think we're always on a continual journey. You know, what my goals were 20 years ago is totally different to what they are now. So you've got to have that flexibility and adaptability. And in terms of some of the tests, yeah, we use a couple of different biological laboratories. I really do like the plant tissue tests. I know they're they are, and I see people talking about doing plant sap analysis. So I kind of think of plant sap analysis and the tissue tests. Like I think the sap analysis is really valuable if you're in a high value crop and you are going to respond to that, because it is very much a snapshot in time. So for horticulture and intensive cropping and greenhouses, the sap test is really valuable. If you're on crops that maybe, like say rangeland or grass, or that you're not necessarily going to take actions on this season, then I think it's valuable to just do the plant tissue test and keep that as your benchmarking and look at, do I start to see phosphorus mobility? Am I seeing nitrogen coming up in the plant? Because that's really telling you that your biological systems are starting to work based just on your management. So yeah, I think there's lots and lots of different tests out there. I think you just want to stick to one and stick to one that makes sense for you. Yeah, and sample in different areas. I definitely want to choose the same soil type and maybe have my best and worst. So on, you know, some properties that could be 10 tests because you've got 5 different soil types. I want my best and my worst. How do I make my worst like my best? Right?
Thank you for that answer. The next question comes from Faith, and since you can't see it, I will read to you, but she also says that you are an inspiration. So,
oh, that's so nice. Thank you.
So she wants to know if you could speak to ways to stimulate the mycorrhizae.
Yeah, okay, that sounds good. Yeah, so there's, if you are, so I would get a mycorrhizal test. So look at a colonization test. So look at, you know, how much mycorrhizae is in the system right now. So, you know, are you over 10%? In rangeland, we should be like 70%. I want to see lots of mycorrhizal colonization in there. So if it's low, I'd get curious first about why is it low? Have those soils been waterlogged? Have you been overgrazing? Has there been an application of fungicides or pesticides or glyphosate, for instance? If you apply glyphosate this season, it typically drops your mycorrhizae the following season by about 25%. So asking that question first, like, why is my mycorrhizae low? And then looking at how do you address those types of issues. So I'm quite biased because I started out really as a worm farmer, but vermicast or worm extracts are one of the best mycorrhizal stimulants, even though they have no mycorrhizae in them. Laboratory work that's been done on it has shown that the addition of 5 liters of a worm extract increases mycorrhizae by 225%, even though there's no mycorrhizae in it. So I like mycorrhizae, I like humates, so soft brown coals as a microbial stimulant, mycorrhizal stimulant. And there are very good mycorrhizal inoculants in this country. If I'm using an inoculant, please ask the company to supply viability tests. They did some testing in New Zealand and found of the 8 companies that were selling mycorrhizae, 0 were viable. So they were basically selling people talcum powder. So ask for those tests. Excuse me.
I've got another question. What is the relationship between high potassium to nitrate poisoning?
Very good. And it's part of that that mineral pathway, right? So what happens is often with high potassium is we see that breakdown in terms of other uptakes of other nutrients. So often with high potassium is it's more an antagonist to those other elements, and we see nitrates come right up. So it's a really interesting phenomenon is to see people applying potassium fertilizers and see their nitrates go up as well, which is then going to affect your food quality. Yeah.
Perfect. The next question is, it deals with bricks. So this person says that bricks is a very variable test. Can you explain why you chose to look at that instead of doing a forage quality index based on fibers?
So it is very variable, and that's why you need to be aware of the variability of it. Like what causes bricks to be, what are the influencing factors? And what you see is all of the best regenerative producers around the world are running high bricks. So even though there's variability to consider, time of day, has it been cloudy? Has it been really cold and wet? Is it the middle of winter? There's so many different variables for it, which is why I'm going to continue to take brick samples through the season. I am still taking a leaf tissue test. I still want to know what is it that's putting a drag on bricks, because phosphorus is going to have a relationship with that, same with calcium, and then your trace elements. So that could be just you're low in manganese and you're wondering why you can't get the bricks up, or you're low in boron and the system is just plateaued. So you need, both of those are good. What I like though is I like tools I can be in the field and get an immediate response from. Yeah.
Perfect. So this question is very personal to Paul, who asked it. He's asking specifically about his soil. So he has very sandy, silty, well-drained soil with very little organic matter. Would cow manure or fish hydrolysate be better? It's a perennial pasture in Colorado at 6,500 feet elevation.
So I'm not a big fan of just putting manures out. I want to compost them first. So if you have got access to a lot of manures, if you can pre-compost it and then put it out, probably getting organic matter out there to form a foundation for everything to bounce off is probably the best idea. Yeah. Rather than just trying to stimulate things, because that might be a little bit slower. But have you got animals? It's really hard to answer specific questions without context. But yeah, I mean, I think actually getting organic material out there. I love wood chips. I use a lot of wood chip if I can. But to like just give biology like a house while you're, working on lifting bricks and getting soil carbon up.
All right, I've got one more question. This one is from Faith again. She's wondering if you have looked into Korean natural farming as a method of producing biostimulants and autoinducers.
Yeah, I'm a big fan of Korean natural farming. So yeah, we do make a lot of those different types of biostimulants. Yeah, I think they're great, and they're so easy and so economical to do. I mean, once you figure out how to not make a bad one. But I use the lactobacillus one a lot. So we use that to clean up in dairy systems or effluent ponds or silage, obviously. Yeah, so no, it's great. I think there's a question here from Willie. So you're saying most soils have enough of nutrients when analyzed? Yes. So plant available in my view, and it's control. And you're saying plant available in my view is only applicable in conventional operations and controlled by pH. As soon as you get a proper connection between plants and minerals, these become available. Mycorrhizae. Yes. Yeah. So if you look at that whole rhizosheath, that plant can actually, in that rhizosheath, can change that pH by as much as 2 units. So you might have, a soil, a really alkali soil, maybe it's like 9. Well, that plant can change around that rhizosheath, can change that pH by as much as 2. So that's where I do think we look to the plant and say, well, what is the plant experiencing? Because if it's got that buffer and that rhizosheath is working, then those nutrients are going to come through in that ideal pH. So all of that work on pH was done in sterile laboratory conditions. And so much of what we see that like, it's conventional thinking that we're trying to put into the regenerative sphere was done in plant pots, in greenhouses, or in sterile conditions. And we really need to look at, well, if we just create a system that supports that biological community and that metropolis of biology, they're the ones that are making these nutrients available in these different plant available forms. So to do that, we need to ensure that we have soils that are well structured. Okay, what's going to drive that? Is that your cover crops? Is that the biostimulants? Is that your management around grazing? Is it you just get as much diversity out there as possible? That example that I showed in the cropping one that had these really tight soils, we put down 30 pounds of gypsum down the drill. And that all that did is it influenced those major mineral imbalances. It flocculated and opened up around that root zone. And now that plant can get down there, feed biology, and start to build those soils. So you got to really look at what is putting a drag on your system currently that's not enabling the biological system to access all those nutrients. Because yes, all the biology, all the nutrients are sitting there, but how long is it going to take you to access them? And, you know, I meet producers that have been doing a great job with, say, they're grazing for 30 years and they still have major trace element issues. If they'd taken care of those trace element issues early on in the piece, I wonder what would have been possible for them. So you really need to be assessing, like, not just assuming or going, oh yeah, biology will take care of everything, let's get the system really humming. Sorry.
Awesome. So Greg is wondering if you are going to tour the West again this summer.
No, it's got too hard. I have to have a chat with a couple people. My Texas events just got canceled, and I'm supposed to be in Colorado, but I think it's going to all be off, unfortunately. Yeah. So much fun. I had 44 full day events canceled. So yeah, this season has not turned out like I thought it was. So much for a book tour.
Then Willie has another question. What is your view using cover crops to improve the regenerative system?
What's my view on cover crops? I think it comes down to context, right? And so we're seeing people spend a lot of money on cover crops and having cover crops that struggle. So you got to look at, well, what is my rainfall? If those soils are super compacted, cover crops aren't necessarily gonna, sometimes they break them up and sometimes they don't. And you find cover crops with roots are just growing sideways, or, you know, tillage radish will grow up out of the ground. It's not a silver bullet, and I guess some of my concerns is people are treating it like a silver bullet, like they think regenerative agriculture is about cover crops. If you have an established pasture that's working really well, or, you know, it's just growing a diversity of grasses, don't go out there and spray it out to put in a cover crop. Like, you see people do that. We've seen a lot of instances in Australia of people actually spraying out ground cover and putting in cover crops that then fail, and then they have 2 or 3 years of bare ground. But you know, I think in a lot of instances, cover crops are absolutely fantastic. But going back to what are your goals? What is it that you specifically need for a cover crop to achieve here? And just seeing it as a transition tool as opposed to a long-term solution. And then, yeah, I think in some environments, they're absolutely fantastic. Animal forage producers and pollinators, and yeah, I mean, I think it's great. Let's get all the diversity out there that we can, but I think we still need to be not thinking of it like a silver bullet.
All right, well, I believe that we are out of time. It is officially been an hour, which is crazy. Thank you so much for speaking with us, Nicole. It's been great. Just a couple of plugs here from Ward. So if you enjoyed today's webinar, we will be hosting a 4-part webinar series entitled Producing Robust Livestock Through Nutrition, Genetic, and Soil Health Management. This has been approved for continuing education credits from the American Registry of Professional Animal Scientists, and will include presenters from the Great Plains Veterinary Education Center, Neogen, the Hagyard Equine Medical Institute, and Oregon forage and nutrition expert, Dr. Woody Lane. So if you enjoyed today, please feel free to look at Facebook for some upcoming events that will probably interest you. We also, if you are in the Sioux City, Iowa area, we also have a ward summit coming up September 2nd and 3rd. And feel free to log on to our website to register for that. We will have day 1 will be focused on economics, and day 2 will be focused on soil health. So if you could join us for one or both days, we would love to have you there. So with that, I will say thank you again so much, Nicole. This was awesome.
Thank you for having me.
And we will sign off. Thank you, everybody.
Brilliant. Have a great day, everyone.